Today, Mars is a cold desert surrounded by a thin wisp of air, but its dry lake beds and empty river channels point to a warmer, wetter past maintained by a thicker atmosphere. Where did the ancient atmosphere go, and with it, the water? To answer that question, NASA's MAVEN orbiter has been studying the upper atmosphere of Mars since 2014. Now, it has witnessed a rare phenomenon that was last seen more than 2 decades ago at Earth. Among MAVEN's suite of science instruments is the Solar Wind Ion Analyzer, which measures electrically charged particles, or ions, surrounding Mars. In this data visualization, yellow spikes indicate the velocity of charged particles encountered by MAVEN along one of its orbital tracks. The largest source of charged particles in the solar system is the Sun, which constantly bombards the planets with a stream of electrons and hydrogen ions. When this solar wind reaches Mars, it interacts with heavier ions in the planet's upper atmosphere. This creates a global magnetic field, or magnetosphere, that deflects the solar wind around Mars in a bow shock. MAVEN's science orbit is designed to probe these distinct regions in situ. With each pass, it crosses through the magnetosphere, bow shock, and upstream solar wind, measuring changes in ion velocity and density along the way. On December 25, 2022, MAVEN encountered a sudden and dramatic decrease in solar wind density. As the pressure of the solar wind dropped, the Martian magnetosphere and bow shock ballooned outward, engulfing MAVEN's orbit. From the spacecraft's perspective, shielded beneath the bow shock, the solar wind had disappeared. In 1999, NASA's ACE satellite observed the same phenomenon at Earth. The solar wind density dropped by more than 98%, causing our planet's magnetosphere to expand to over 5 times its normal size. These rare events occur when a fast-moving region of the solar wind overtakes a slower-moving region, leaving a low-density void in its wake. As quickly as the solar wind had disappeared from Mars, it returned on December 27th and squeezed the magnetosphere and the bow shock back to their usual proportions. MAVEN could once again feel the solar wind blowing across its instruments, and it could continue to study how Mars had evolved from a wet, hospitable planet into the cold, dry world we see today.